when you're looking through a problem like this story problem, where it says you're looking at an open box top constructed out of a sheet of plastic by cutting out squares from each corner. Okay, so the idea is that you are removing some squares at each of these corners so that you can then fold the box up where sort of along these sort of perforations here to create an open top box. Okay, and so you don't know what the size is. So we're going to call the size of the squares that you're removing x by x. So that's your unknown side, and you want to find out what size you can use to maximize the volume of this box. Okay, so if you think about what's going to be created here, okay, so what will be created is a box that kind of looks like this, okay, where this dimension here is this piece. Okay, and so if you know the original dimensions are 20 by 14, you can identify that this piece right here is going to be this length of 14 minus what? What am I removing from each end? X. So how many x's am I removing total? Okay, so there's the dimensions I'm looking at here. And then this length right here represents this length on the folded up box. And this is going to be, again, if I take this whole length of 20 minus the x on each corner, this dimension will be 20 minus 2 x's as well. And then the height of this box is going to be this measure right here, which I can see is x. So I can find the dimensions based on this sketch. And so when I calculate my volume is going to be a function of x, whatever the measure, the squares that I cut out. And I know it's going to be the product of all of these sides. So it's going to be x times 14 minus 2x times 20 minus 2x. Okay, so this right here is my polynomial that gives me my volume. Okay, so in order to maximize this volume, what I need to do is I need to look at the sketch of this graph, okay, and see where I have a maximum. Okay, where is my max value? And so this is something that you, even though you could find your intercepts here, you know that you have intercepts at 0, 7, and 10. Okay, you can find those. You could sketch. I could have you sketch what the graph looks like. But in this particular problem, it specifically wants a value that is a maximum. So you are going to need to look at the graph on your calculators. So here's how you would do that. So if you go into your calculator, what I would do is go into the y editor, and I would enter this function in your y editor. Okay, so x times the quantity 14 minus 2x times the quantity 20 minus 2x. So there is my function. Once you have your function entered in your y editor, what you can then do is go in and view it on your graphing window. Okay, and so the graphing window is here. The diamond F3 opens up your graph. And now it should be set to a window setting that is probably the default, which is a minimum at -10, a maximum at +10 for both the x's and the y's. So notice I don't see much of this graph here, right? So I see the intercepts. So I have 0, 7, and 10. So I see my graph goes something like this, up here, then down, and then back up here. But I can't see where that maximum point is. Right? And so what I need to do is I need to be able to zoom out to see it. Okay? And there's a couple different ways that you can do that. Okay? You can do trial and error, or you can kind of make some estimates. If you see where your intercepts are, which I identified here, I can go into my window setting. So diamond F2 allows you to change what the mins and max of your viewing window is. So my x's, I just need to make sure I go up through 10. Okay? So I'm going to go ahead and make my max a little bit more than that. I'm going to go to 15. And my minimum has to be 0. So again, I don't need to change it. I'm just going to leave it -10. I could put it -5 if I wanted to. But I do want to see all of those intercepts. Now, my y's are a little bit different. Okay? I don't know how high I need my y's to go. So what I could do here is I could start using powers of 10. And so one of the easier ways to sort of do this on your own is to use powers of 10. So my minimum doesn't matter. I'm just looking for the 0. So negative 10, I can keep that as fine. But if I increase my power of 10 from 10 to 100, right? So I went from 10 to the first to 10 to the second. What I can now do is go back into my viewing window and see, do I see everything I need to see? I still don't, right? I still need to get higher. So I can go back into my window, change my viewing by a power of 10. So I'm going to go to 1,000, right? So do you understand what I'm saying by power of 10? So 10 to the first, then set squared, then this is 10 cubed. So I'm going to enter that, go back in, and view. Now I see what I need to see. Okay, so using powers of 10 allows you to find the part of your graph that you need to see relatively easily. Okay, so I know that my maximum value is going to fall somewhere here, right? Because this represents 10. Anything beyond 10 isn't even going to be, even though it goes up higher here, it's not going to allow you to have one side of this figure. So it needs to be somewhere in here. And actually between 7 and 10, it's going to be negative. So you know that your answer has to fall somewhere between 0 and 7. Again, not necessary, but just giving you a little bit of information to help interpret what the graph is indicating. So I know my maximum volume is reached somewhere between 0 and 10. And I see it's going to be right here. I can point to where it is on my graph. But in order for me to find that, you're going to use what we did earlier for max and mins, the extrema. Right? And this is going to use this math tab. So the F5 math tab allows you to choose a maximum value, which is option 4. You just need to set a lower and upper bound. When you set your bounds, the bounds represent x values. So I'm going to scroll left and right along my graph until I know that this crosshair is somewhere below and to the left of my maximum point. So does everybody see? Again, there's no question that my maximum point of here is that this crosshair is below and to the left of. That's my lower bound. I'm going to hit enter. As soon as I hit enter, this will change to the to upper bound. And now it wants me to set my upper bound. Okay, and so by setting these lower and upper bounds, you're going to identify what the maximum point is between those two those domains, between that boundary. So I'm going to scroll along my graph again, left and right. I'm going to move to the right until it starts to go again to the right and below this maximum point. So anywhere along that is fine. Where my crosshairs sit right now is to the right of and below this maximum. So once I hit enter here, it's going to give me the coordinates of this local maximum, okay, this relative max point. So when I hit enter, I see that my maximum is about 2.7. Okay, and my output, the volume output, is 339.01. Okay, so based on what I see right here, this is the ordered pair of my relative maximum. Okay, and so what the question is asking me, and it could ask you one of two things. It could ask what is the maximum volume that can be enclosed by this box, or what size should the squares be that you cut out in order to maximize that volume. Okay, this ordered pair of the relative max gives both of those pieces of information. Here's the dimensions of the box that should be cut out, the x value, and here is the maximum volume, which is your output. Again, you see volume's a function of x, and so this is the maximum volume that can be attained. So your answer for this particular question would be 2.7.